Now the components are getting a little above the QRP blocks, so it won't lay perfectly flat anymore. We'll just have to live with that. Well, what do we have here? An LED. There's a flat side on the LED. There is a flat side right here. The long lead is positive and is opposite from the flat side. Then it can fall in and lay against the board. There's 4 terminals here and 9 terminals here. The kit includes two terminal blocks, three terminal blocks. They can just be dropped in these holes, but I prefer to fasten them together. If we make them face the same way, find a little groove here and a little tongue here. Come on, focus. A little tongue rising vertically. Put the tongue in the groove and slide the blocks together. And now I've got a block with 4 screws. Make sure the wire holes face out this way, and they'll fit that way. These are pretty stiff, so I don't normally bend them. I have a pair of reverse acting tweezers, and I just hold the block against the circuit board this way, solder one of the terminals, look at the block, make sure it's square, tight, then proceed to solder all the terminals. We'll do the same thing with a 3 terminal. We'll put 3 terminals together to make 9. Well, we're practically on the home stretch. We have 2 electrolytic capacitors. They're the same. Long lead is positive. Short lead is indicated by the white marking on the capacitor. Conventionally, the notation is the negative side is shaded like this. And that's the way I did my drawing. I do have a little plus sign there, but when you see this shaded area on an electrolytic capacitor, that indicates the negative side. And the unshaded area is positive. So long lead is positive as well. Just push them in and set them down. We have a relay. The pins tend to get bent in shipping with these. So straighten the pins out a little bit. It only fits one way. It says relay. A little bit tight. I had to force it down against the board. That's okay. Just make sure that all 8 pins are started before you squeeze it. It should lay flush against the board like this. As far as parts included in the kit, we only have these. The way I like to install heat-sinked components. Now, this is not intended to be insulated. Bear in mind that this, without an insulator, will put this heatsink at the positive potential of the output of the supply. Not having an insulator also makes great heat transfer possible. Even though we're not going to use an insulator, I will put a little drop of heatsink compound between the rectifier and the heatsink itself. It doesn't require much. Now, do not tighten this. Leave this a little tiny bit loose, because we can access this screw. So the heatsink itself mounts on the circuit board with these 2 pins, here and here. So with the device a little bit loose in the holes in the heatsink, and the heatsink and the relay work together upside down to position this thing nicely. So that works out well. We want to first fasten the heatsink to the board. In other designs, this may be done with screws, bolts, locating pins, but the heatsink should be mounted on the board. Solder one terminal, and then eyeball the heatsink to make sure it's vertical, it's tight against the board, and finish securing the heatsink. Do not solder the device yet. Once the heatsink and the board are in place, tighten the screw. Once the screw is tight, then go ahead and solder the components. Had we soldered the component first, that is before we tighten the screw, tightening the screw might introduce some stresses. It's bad enough there'll be thermal stresses when it heats and cools. We don't want any mechanical stresses locked in. So there it is, tight, the sink is positioned. Then we can solder these things. Now the board designer apparently allowed for another full wave device here. We don't need another device, we have one here. But it looks like he provided these holes for a bigger device that is physically bigger. There are no other unused holes except for the mounting holes and these 2 holes for these capacitors, 2 holes each. I've elected to use the 10,000 microfarad units. The only thing critical here, we've got the 2 black circles. I think this is a 30 millimeter and this is a 35 millimeter diameter. They both require 10 millimeter hole spacing. If you elect to use this grounded, electrically grounded mounting hole. You can't use the large capacitors. You'll barely be able to use the small capacitors. Negative, negative. They go this way. And you notice you could barely get a screw in there. If you use the next bigger size capacitors, you won't. So the board won't easily sit on these capacitors. Hold the board down while I put one of these, while one of these leads is soldered. Here's the completed kit. The first three terminals are the power transformer. These three here. Then these two are positive voltage out. That's this one and this one. Ground, and left and right in. Over here we have left out, ground, and right out. So amp provisions here for two amplifiers. Two positive outputs, two grounds. I've got this toroid. It's the Antec brand. These are available on eBay. They are great. This particular transformer has two primaries, rated 115 volts. I can connect them in series or parallel for a 115 volt input or a 230 volt input. I have two 24 volt secondaries, blue, green. I'm going to connect a green and a blue together. That will give me 48 volt transformer center tapped. This transformer has two secondary windings. Each will provide 24 volts. Each has one blue and one green wire, but which blue and which green constitute a continuous coil? Poking around with an ohm meter, I was able to find out that this blue wire and this green wire are a pair of wires that provide 24 volts. And these two are the second winding. In order to connect these in series, I'll take a blue wire from number 1 and a green wire from number 2 and connect them together. Then I'll have the remaining wires, and this is 48 volts. 24 plus 24. Or if I'm measuring from here, it'll be 24 volts here, 24 volts here. So we need to identify which pair of wires go together. I've got the kit completely done, powered up, 48 volts, center tapped. I've got a green LED on the output of the main power supply. That is the output that would be used for an amplifier. The red LED indicates when the speakers are connected to the amplifier or when the relay operates. I'm going to turn power on. You'll probably hear a loud click, and this should instantaneously light. And now we have the relay. Try that again. Probably a second and a half delay. You count. Maybe a little quicker since I'm cycling it fast. Watch how the red LED increases in intensity. So the green LED is connected across one of these outputs and ground. The red LED is connected in parallel with the relay coil. As the voltage rises here, which is reflected by a voltage rise taking place here, that LED slowly begins to light, and at some point the voltage across this relay increases, current through the relay increases until the relay throws over, connecting the input to the output of the speaker wiring. With 48 volts in, or 24 volts depending how you look at it, the output measures no load now. .32 volts. The AC, .47 volts, or $23.9. So 48 volts center tapped gives us 32 volts of output. Well, I hope you enjoyed this little video. It's a nice little mind-soothing kit, if you will. It's easy to put together. It doesn't do a hell of a lot. Thank you for watching.